So my name is William Young. I'm a security solutions architect with Cisco Systems. I wanted to talk a little bit about how we deal with the nature of encryption nowadays. So I've been in this industry for, gosh, just shy of 30 years now. And wow, that's really a long time. And we were always huge advocates of saying, we need to encrypt, we need to encrypt, we need to encrypt, right? Makes sense, right? Encrypt data in storage, encrypt in transit especially, because we've got data that's important, it's critical, it's sensitive. Bad guys love encryption, which is really a challenge for us. So of course the answer was always, hey, well, we'll decrypt, right? But it's really not an easy thing to do, and it would be counterintuitive to do that. So we need to look at how we approach encrypted traffic in a different way, especially because we know now that the majority of traffic on the internet is going dark. We're not going to be able to start looking for threats because, frankly, as an attacker, when I play an attack role, I embed stuff in encrypted sessions, right? I don't want people looking at my attack media. Google's actually validated what NSS has been saying in their reports on where encryption is going. Google's saying about 80% of the traffic that they see in all their Chrome environments and Android environments is encrypted. A few years ago, Apple even required that all of their apps use TLS encryption to ensure communications are encrypted in transit. So it really gets to be a challenge now, right? How are we going to be able to look at this, especially since decryption is expensive and it usually doesn't work? So what I want to do is take a look a little bit through what the encryption challenges are and what are some strategies around that. Now, just sort of to cover the bases here, some of the slides are going to look a little product-y. I tried to de-productize them. And instead, I want you to listen for what the overall sort of message and thinking and strategies around encryption are and how we can try to address that. So it's a challenge, right? I know when we first started selling decryption capabilities, we were charging about $40,000 a gigabit, and the price hasn't really gone down much, right? And it's because it's expensive. It's challenging to decrypt traffic, and that was in the earlier days of just SSL decryption. If I had the keys, I could deal with it, maybe deploy a man-in-the-middle decryption. But it's changing, right? With things like certificate pinning, with TLS 1.3 coming out, it's getting harder and harder to deal with the ability to decrypt traffic and looking for threats, especially because it also deals with privacy and compliance issues. We're trying to deal with how we manage and maintain data. It's going to be more and more complex even as we go, and we're going to see a little bit of what that looks like and what I mean by that. Classic point. If I want to decrypt traffic between, well, just about anything in Google nowadays, I can't. Right? It's plain and simple. If certificate pinning is involved, the apps won't work. And we see that with a lot of apps out there, which now means things like trying to do traffic inspection for data loss prevention goes out the window. I can't do it. It means trying to look for embedded threats. I can't do it. All that ends up happening is there's a session going on that I can't do any type of negotiation in. Quick question on the room. How familiar is this room with how decryption works, how SSL decryption works? Okay, only about a third. So I'm gonna do a simple version of it. Basically, the way you do SSL decryption is a man-in-the-middle attack. Right? So it's real simple if I own the keys, right? Someone's trying to come into my environment, I own the certificates, I can decrypt that traffic very easily, right? Because they're coming against my servers. But if my users are trying to go out to the internet, traditionally what I'd have to do is I'd have to proxy that session. I'd have to capture the certificate, re-sign it. So essentially the user is signing an encrypted session with me, and then I retransmit that traffic out on the other side, signed the other way. But what ends up happening, of course, is the user is getting a cert that doesn't say it's from, facebook.com. So their browser should technically throw out an error message saying, oh, wait, you've gone to Facebook, but that server is willyoungshacknet.com. Not going to work. Of course, most users just sort of ignore that anyways, and it worked fine. But you set up an internal certificate authority. You can make it look good, but it's still just hacking the SSL session. So we needed to find a way to get past that, and thus folks do things like certificate pinning, which is essentially like a self-signed cert for doing the key exchange, where it's, I own both ends of the devices, I can handle and manage that sort of trusted negotiation between them. It breaks that man in the middle of the attack. Add to that, we're seeing a lot more, well, really a lot more encoding, right? With things like HTTP2, we're now being encrypted with TLS. We're looking at binary format information that becomes a lot harder to be able to manage, a lot harder for me to rip open. And another example, Google, it's their own variation on certificate pinning, just as a way to be able to say, I've got client-server communication that I'm not going to be able to look at. Now, as an exploiter, I love this, right? Because I don't even have to start embedding my own encryption technology inside of it. I'll just leverage the infrastructure that's out there, right? I'm going to attack a server. Well, I'm just going to attack it over HTTPS or TLS, and everything is going to be delivered from an exploit perspective in. Same thing for data leakage and whatnot. So I need to find other ways around this. Now, what I encounter a lot with my customers is, well, we want to do this in the firewall, right? Makes sense. We've got something in the middle, and we can. There's a lot that can happen there. The idea is very simple, right? I have a SSL policy that's going to maintain some rules about how I handle SSL and TLS traffic. And then once I've made those appropriate decisions, I'm going to either decide what to decrypt, or I'm going to go on to doing some additional inspection for application control, for intrusion prevention, where I'm looking for threats. And hopefully, I'll be able to get into it. The challenge is I can't always. So I need to start looking for other markers. The traditional thinking of just saying, oh, well, we're going to decrypt the traffic, it's kind of nice, but frankly, it's computationally expensive. I don't always have control over the certs, and it breaks trusted infrastructure in a way that users suddenly don't work well with it, and many applications start to fail. So let's check other things. Right, there's other artifacts around encrypted traffic that we can try to leverage. And so you want your next-gen firewall to be able to look at something like a TLS client-server negotiation and pull out things like the domain name, right? So here's the question. Am I actually decrypting traffic in something like this? That's right, I'm not. All I'm really doing is enforcing domain access, right? So I might be able to say, oh, okay, there's a certificate coming in from example.net. I can see that from the SNI on the cert and try to be able to decide what I want to be able to allow or not allow. So I'm really making an access control decision based on a label. And that's fine, that's not a bad thing, but it's not helping me see the embedded attack. It's even worse in 1.3 because now I'm getting more of that information encrypted, right? So that server name, the actual server information is actually Diffie-Hellman encrypted now too. So it's getting harder. Everyone with me so far? Okay, good. Well, assuming I can, the traditional thinking was always, well, if we can decrypt it, let's decrypt it, let's look for threats. But really, I'm now just into threat mitigation. So I want to at least be able to control what I can control and not. And that may be by domain information, may also be by structure, right? So instead of just oops, which button did I hit? I want the green one. Hey, there we go. So what I can do is make decisions on the traffic, whether it's inline and I'm trying to do some certificate inspection, or I'm working passively. Ultimately, the goal is to try to figure out some conditions around that cert traffic that I want to be able to make a security control decision on, right? And it may be doing things like we've done before, where we capture the cert, we re-sign, we act as that man in the middle, only replaces the key, but of course the user sees it, the applications break. Those are data points though, right? And I can also leverage data points like the sites that are decryptable and undecryptable. Do I actually want to allow users to go to organizations that I can't decrypt on? And that may be appropriate for some parts of my traffic. Certainly if it's an inbound session coming to one of my assets and I can't decrypt the traffic, I've decided I'm going to allow that type of decryption. Maybe I don't allow that session to ever establish in the first place. Make sense? Because in a scenario like that, it may be an attacker using a self-signed key on some malware distribution that they've deployed. That makes sense to control that. And we found that right now, putting controls on things like self-signed keys, improperly formatted keys, improperly formatted certificate matches, are ways to reduce threat exposure. And they can reduce threat exposure fairly dramatically just because the attacking landscape is still using a lot of self-signed certs, or they're using certificate authorities that are, frankly, not the best certificate authorities in the world. Right. Big things to look for: excluding self-signed certs, looking for errors, looking for miscommunications, looking for anything in the structure of how that communication establishes to try to be able to control. Essentially, all I'm doing now is implementing an access control on the structure of the policy, or on the structure of that communication. I'm not really getting embedded in the content, and I'm not really looking at threat. And all this is doing is just validating that it's good content. And it does help, but I want to be able to get deeper than that, right? I don't want to just block sort of indiscriminately on things that may still be valid sessions, or things that aren't actually threat enabled. So if I'm going to do this, I need to have a better way, right? I can't just go through and try to look at things like, the actions to take on any specific type of SSL or TLS session. I actually want to build something a little bit richer. Now, one way to think of this is to actually offload it. So one of the huge challenges we've had with decryption is cost. How many organizations here actually try to do SSL decrypt on their traffic? Anyone? One hand. That's awesome. That's actually not surprising at all. In fact, I was almost expecting, I was only kind of thinking we'd get at least 3 or 4. Big reason I find is that it's just too bloody expensive. Right, to do effective SSL decrypt is costly, and as you saw, I've got to start making all these decisions on what the structure of that traffic looks like in order to become effective at it. So one thing we've started seeing happen is, well, offload it to the cloud. So we've been doing this at Cisco with some of our customers, and actually creating an environment where we will allow customers to be able to get their SSL decrypt offloaded into an external sort of security service gateway. Right? The idea is proxy traffic out one particular direction, whether it's web traffic or whether it's all traffic. You make decisions on that, and you rely on your service provider to make intelligent, informed decisions on what to decrypt and what to encrypt, or what to leave alone, or at least to put threat information on. But really, all I'm doing is sort of offloading that management of it and hoping to reduce cost at scale. I'm not really getting into the structure of what threat may be. So, if I can't do decryption, what else can I be left with? Well, the way I look at it is I need better threat intelligence. Right? And a big part of what we're finding is that we have a massive amount of data available to us globally around what threat actors look like, what they're doing, how they behave, and how information sort of works. There are artifacts and indicators that we can use to be able to say, with confidence, this is a session that I would not want to allow, even without doing decryption. Right? And I'm an old IPS guy. I like to be able to look at the packets. I like to be able to sort of do a raw decode and be able to say explicitly, this is where the threat is inside the code, but it's too expensive to do that. So instead, I want to start correlating observations from external sources and behaviors on my internal environment in a way that starts to bring data together so I can point confidently at session activity that may be threat embedded. All right? So where do I start? Well, the easy things are things like IP addresses, IP reputation, URL reputation, assuming, of course, I can get the URL. But all of these become elements and factors in allowing what is and should and should not be connected to. Domain name requests is another big one. And so we've started finding that if we track things like the reputation around specific domain names, and not just your average facebook.com domain names, but the domain names that are being generated algorithmically. We see domain name generation happening very rapidly. We'll see new domains pop up within 20 minutes. The entire internet can access them. Well, is that a good domain or not? And if it's constantly rolling new domains to the same IP addresses, that's potentially a threat actor or a video streaming service, which is kind of a threat actor. But those become artifacts that I want to leverage. So how am I going to do that? Let's start taking a look into that. Oh, the other point to think of is vulnerability information. So I'll get a little bit more in depth on the nature of how we start pulling all the threat intelligence together. But the other thing to keep in mind is just the nature of vulnerability. Right? We know actually a lot about what's getting compromised and how things get compromised. And that also means we can start seeing and understanding what those artifacts look like under different stateful conditions. So it doesn't mean just because I know how an exploit works in sort of the old-fashioned way of looking for an attack on an intrusion prevention system. Oh, I'm going to look for this session connection request, I'm going to look for this buffer overflow instruction, and I'm going to say that packet's the bad packet. I can actually find characteristics in a larger session behavior, whether it's domain information, whether it's file transmission sizes, whether it's actually packet structure of encrypted traffic. And so we use this data as well to try to analyze it. So how is that going to happen? Right, I need to find threat in an encrypted traffic session. Well, I leverage massive data analytics. Right, and that's actually part of what we do now. One of the things that Cisco's been developing is something we call encrypted traffic analytics. This is where we're actually doing massive analysis on all of your SSL traffic activity in conjunction with web proxy data, in conjunction with enriched NetFlow data that we can identify with a high degree of confidence where there's malware, where there's crypto mining, where there's malicious content embedded in the HTTP traffic. And that's all through data analytics. See, the idea is what we're looking at is pulling in enriched data, largely through NetFlow, but we use that data in real time against a much larger data environment that's been running analytics against what exploitation behavior looks like on the internet. Right, and so with that, we start to put together a mathematical way of determining where I've got malicious content. Really, all it takes is two elements. Right? I need the initial data packet, and I need NetFlow. And so I get a massive amount of NetFlow coming into my analysis engine, and then we look at that initial data packet, which may give us information about the structure of the SSL, TLS traffic. It may also give us information about really what the size of the session is going to look like, what the behavior of that particular content, how it is established. And what we have found is that we get a 99% degree of accuracy in finding threat inside of the traffic. Now, we can't tell you things like what data is being stolen, how that threat necessarily exploited your specific environment. Those artifacts aren't available to us because we're not decrypting. But we are actually able to point to it. This is a massive amount of data analytics that starts to bring information together, right? All by using more data. It's leveraging the information that I know about the inside of my environment, that we can see about how your internal behavior applies, and comparing that in real time with the threat landscape. Now, the other way to look at this is to just turn inward, right? If I can't look at the traffic, maybe I need to go back to looking at my hosts, right? And that's where things like network behavioral analysis becomes important again, right? Any folks do any heavy NetFlow analysis or NBAR functionality inside your network? Well, if not, you may want to consider it, right? One of the biggest indicators for compromise, the biggest indicators for problems in my environment is something changed. And it changed outside of my expectation of what I consider a whitelist. Now, with better NBAR tools, what I can actually start doing is monitoring for those change realistically. You know, it used to be very easy to say, it's just too many things. Every single workstation, every single device on my network is constantly under some state of change. But it actually, with better data, richer data, and better analytics, I can actually start analyzing that information in real time and automate the analysis of it and look for behavioral characteristics that are outside the norm. That might be something as simple as a device is suddenly spewing out new services, new network services that's never occurred, or I've got HVA systems talking to a foreign country that they've never talked to. Right? So the behaviors can be pretty broad, but I want to start looking for those behavioral indicators that show that there's a potential problem, show that I may be interacting with a command and control environment, show that I suddenly have session activity that's outside of the norm for the behaviors on sort of a macroscopic scale for that particular environment. Those change indicators are usually indicative of a problem. Sometimes it's IT, more often than not, it's actually security. Right? Some type of threat scenario is embedded inside of that. I also want better host investigation right down to the details. So that actually means being able to profile the behaviors of that specific device down to things like identity. What's the configuration of the device? What is the overall flow and behavioral characteristics around that device? The more I can know about the endpoints that are actually interacting with them and sort of put a fence around those components, the less I'm actually worried about encrypted conditions. Make sense? Right? So now I've talked a little bit about monitoring the change. Cloud. Yeah, I don't like that title. I think I might have to change that one. But what I'm really getting to is, you're noticing we're talking about a lot of data, right? And it's not like I can just stand up a server and say, okay, this is going to be my data analytics box inside my network. I need to find ways to be able to start bringing all of this data together and tying the pieces together. And so am I really looking at just threat embedded in traffic? Am I trying to understand what reputation information is from IP addresses? I need to start understanding what host endpoint configuration and change looks like. We can use the cloud as a way to help deliver some of that. One of the easiest and simplest is just leveraging domain name services. One of the things that we'll do is we'll help and monitor DNS calls and lookups. Right? Because one of the things that I can prevent is infection and compromise just by disallowing a connection to happen. Remember, domain name services are essentially the yellow pages. Does anyone remember yellow pages? Or white pages? And I don't mean the .com or .ca versions of them that are just ad engines. Man, I miss the yellow pages. Some days I want analog back. Well, what we do here, and what we've been trying to build with, say, Cisco's umbrella solution, is a way to be able to look at DNS in real time as it's being propagated. So this also means watching how new domains get generated, what's being built out there, and building massive models around threat intelligence on IP and on known malware that we're seeing from other agents of information, and being able to associate that with domains as they're being generated. And not just, little Facebook.com ones, but actually fairly complex domain names. We've got scientists who work on whole new methods of domain name generation prediction. But all of that means now when my device is given some malicious URL and goes out and calls it, I know how old that URL is. I know how many other artifacts have gone to it. I know who else is asking for it. I know if there's malware associated with it. Am I going to allow it to be connected to? Probably not. I'm going to actually come back and give you a different IP address for that domain request and say, yeah, you don't want to go there. Right? It's very simple to do. The user is given a URL, they're given a domain, they make a request. All we have to do is be the authoritative response. And it propagates very quickly, requires no physical infrastructure, it's very fast. And it's a preventative method. It's not actually getting into the encrypted traffic. All it's doing is saying, look, these are domains that we know are potentially bad, that we know are malicious, and I may have actually received that over an encrypted session because attackers are using HTTPS now. But what I can also do is use that to leverage how I might handle the traffic differently. So, for example, I used to run DNS or HTTP. Let me start that again. It's my morning too. I used to run SSL decryption inside of my own network environment. Now, I say my network environment. I really just host a network of about 150 devices that are owned and run by the 5 people who live in my household. I have 3 teenage daughters, so we have a lot of IP information moving around. But I did want to decrypt some of that, and I didn't want to have to continue running it inside of my house. I actually found that when I was running the SSL engine, my electric bill went up by 3%. It was just that much more computational effort was going on in the box. So what we did instead was I decided to proxy based on DNS, right? And so now what happens is on specific DNS requests, if it's potentially malicious, I'll have that session do so. And it scales fairly quickly because all of my users, all of my devices trust this particular DNS provider as an authoritative entity, and they've got the certificates embedded inside it to be able to allow that. So they've got a trusted CA path that I'm part of, And there can be that man in the middle of the attack, at least for things that are easily decryptable. So they can at least send that traffic off to some other AV engine, some other tool. But the key one I think is really important here is the file inspection. Because instead of just doing traffic redirection, I need to look at content that's coming down as well. And I'm going to get to that one in just a moment. But if I at least know which and where, I can start trying to capture that malicious content before it comes into my environment, if it's even going to be allowed. And the real decision is simple, or is a little bit grayer than that, I mean. Is if I know it's bad, obviously I'm not going to allow them to connect, right? And if I've got a high degree of confidence it's good, I'll allow the sessions to happen. It's the things in the middle. It's the things we don't know. We don't fully know about that domain. We don't fully know about that session. That's where we're going to want to send the traffic off to some type of file analytics, assuming I can decrypt the session. If I can't, I'm going to have to come and deal with it another place, right? Because I'm not always going to be able to deal with it on the wire or over the internet. At some point, I'm going to need to be able to take that information, bring it down to an actual sandbox. Now, if I'm lucky and I've been able to decrypt the session, I'll take the file and I'll throw it into a sandbox, where we take advantage of something like Threat Grid to be able to do full file investigation. Look at that file object, tear it apart, start ripping out the artifacts. And this is actually how we start building out a lot of the intelligence around malicious domain names, around malicious IPs. Right? And if I've got a file object that I can sort of explode and let execute in a safe environment, I'm not trying to just identify that it's malware. I'm trying to be able to identify what its secure communication practices look like and give it to my encrypted threat analytics team. I'm trying to pull out the artifacts for known malicious IPs. I'm trying to understand how it does domain name generation so that I can actually try to replicate that computational capability inside my own analysis. I'm looking for endpoint artifacts, things that are being changed in registry keys, files that are being modified, system calls that are occurring. All of that becomes data that we can leverage in other platforms to be able to look for exploited information. And maybe it's from that file I was able to decrypt. What that does do is it gives me some scale, right? I'm no longer looking at just having to do this at a single point of sort of choke point inside my environment. I can offload some of the compute, I can spread it around. But scale's not enough, right? Because it's still going to get in. I still have encrypted stuff. It's still too expensive to fully decrypt everything. I still can't get rid of everything. So what's that leave me? I've got to put more security functionality inside the endpoint, right? Because ultimately that's the game. That's what the attackers are going after. We all want to get access to that end device and control that. Because that's my way into your organization. That's the way into your data set. So I'm going to go after that in any way I can, whether it's an IoT component like a web camera, which are the easy ones, or whether it's my employees who are sitting in the local Tim Hortons. Those are the super easy ones. Those are the really easy ones to hack. So I need better endpoint controls. Now, I've got some of our products up there. I'm not going to focus on the products themselves. I'm going to focus on the capabilities around them, right? What is it I want? Well, I want some way to be able to, on the endpoint, know what the device is. I need to know its posture and its profile. How is it configured? What's it doing? Who's using it? So I need a good sense of identity that I can have a high degree of assurance on. I need a way to be able to understand how it's interacting with the internet, regardless of whether it's on my network or not, and enforce that policy regardless of where it is. Right? So something that allows me to be able to track its DNS activity, capture that information, ensure that it goes to a trusted component. And I need to have visibility into the actual file system, into the system calls, into the process execution activity that's going on inside of it. And because that's where I can start monitoring for change and where I can start leveraging controls. None of those are encrypted. Right? Those are all things that have clear, simple signature components on that I can start putting additional degrees of assurance on. Right? So if it's a trusted asset with a known user that has the right protections on it, then maybe I'm going to start allowing this. Really, all I'm trying to do is raise the access control bar, but it's also giving me good intelligence about the types of data that may be occurring inside the device itself. Right? I need to be able to do this on or off premise. Right? And so this actually expands a lot more than just saying, oh, I want a VPN back into my network. In fact, I think we've got Duo speaking later today. Is that right? I don't remember. You guys know? No? Okay. I'd heard that they may be here, so I didn't know. The only reason I mention that is because that's another tool for doing not just multi-factor authentication, but identity awareness. Right? So a big trend in sort of handling and managing how we deal with threat was to say, oh, well, we'll just run everyone back into our enterprise through good VPN, which is really just saying, okay, I'm going to encrypt the traffic into my network so they can go out over an encrypted tunnel to an attacker who's going to bring it into there. It's really just creating a longer path for the attack chain, right? But the attack still occurs. So I need to be able to VPN isn't really the answer. All that does is say, here's what we consider a quote-unquote trusted path to application services that I may want to deliver. I don't actually need that. What I need is strong assurance. I need to know who the identity is. I need to know what the configuration of that component is. I need to be able to tie all of those things together to be able to allow access. Technologies like Duo allow us to be able to do that. Duo is well, I'd say it's a multi-factor authentication solution that Cisco recently acquired, but it's really a lot more than that. It's about being able to identify the posture and configuration of the device, associate that with identity, and associate that with policy in real time. Right? And if I got anything wrong, well, if there's a Duo guy in the room, you feel free to chew me out later. So ultimately, that's what I'm looking at, right? Really just improving access control, but gaining better visibility. And we can do that with more than just the posture. We can also do that with the traffic. Right? Good endpoint intelligence, why not give me NetFlow? Right? Allow me to actually be able to see session activity, tie session activity to a specific process. Right? So that when I see any particular network file characteristics, I know which process associated with that, I know which user was associated with it, I know which device was associated with it. And start bringing all of this together. So that's actually one of the things we started trying to do inside of AnyConnect is run a network visibility module that allows me to see that device's behavior regardless of where it is on the internet, whether it's on my network or outside, and be able to capture that type of NetFlow information and intelligence about that particular component. And I leverage something like advanced malware analysis. Actually watch the file system, watch the memory space, watch the process execution behavior, watch what those processes are doing in times and spaces and places where they're not encrypted or where encryption doesn't matter. Right? An encrypted object at rest that is known malicious, it's still known, right? We can still fingerprint that object for the state that it's in and try to capture it. We can monitor file and network intelligence and interactions on a global scale and report that back to a common identifier so that I now have different ways to be able to look at that same object from multiple perspectives. Think about this for a second. If I've got a malware analysis tool watching behavior, process level behavior on my endpoint that I can associate with network intelligence information and say, oh, there's something unusual here. My network behavioral analytics is saying there's something unusual here. And suddenly I've got a whole bunch of domain requests to things that are unknown and unusual from that particular device. That starts to raise the level of concern around it, right? I'm seeing behavioral changes from two different directions. Maybe I'm lacking identity information on some of the process activity, which would be a problem because the process was probably created by a spawned malware that's generated a new user or a new identity, right? I've got things happening that aren't really kosher for what that traffic looks like. I've got correlating information coming from the outside world. Is this the type of thing I want to control? More than likely, yes. Right? Because the number of unknowns and sort of data missets become a problem. We get that kind of data with being able to look at everything from process information, file behavior, network I/O, compare that with other artifacts, and do so on a global scale with good threat intelligence. Right? So that did mean having to build out larger threat intelligence capabilities, and I'll talk a moment about that. But I need to make sure I get all of my devices too, and that can be a challenge. Right? So, hey, there's mobile device management tools, MDM, which is kind of great, but MDM kind of depends on the platform as how it works. Right? For example, these lovely pieces of Apple glass were notoriously hard to protect for a long time, and the big challenge was just being able to get deep enough into the system to be able to control it. Right, to actually be able to see what's going on. Because what would end up happening, of course, is that there are applications that are using their own custom tools for certificate pinning, for other behaviors. They've got their own sort of proxy. They've got their own sort of VPN. I've got really no control of how they were handling DNS, so I needed to get better at that. And the idea was deep process integration. Right now, we've been able to do things like this on other platforms like Android and whatnot, but really when I'm looking at mobile device management, I need to look at this regardless of the platform, which means I need to be able to control things like domain name service requests. Right? I can't just let anyone provide that. I need to have policy around it. I need to be able to identify the component that does so. I need to be able to see every single process that exists or application that exists on the device. I need to actually be able to identify the identity of things of the people that are interacting with those components. And most importantly, I have to have it be entirely invisible to the user. Right? They can't actually have the experience of, oh, okay, I need to VPN into this thing because going over here to VPN to the company to be able to get my mail, that's a hassle, right? They're not going to end up doing it. They're going to find workarounds, or worse yet, it's going to destroy the performance of their device, and they're going to be even grumpier. We don't want to be in the way. We've had that problem too much in security already. So by integrating good MDM all the way down to the process level, and I'm going to really not say MDM anymore because I don't like it. I want something that's really more of a security connector. Right? I want something that's actually as close to ring zero as possible that allows me to be able to identify the devices, get full posture, negotiate and manage how domain interactions are occurring or DNS interactions are occurring, and be able to capture that same sort of process level and file I/O and network I/O behavior happening on any device. So how do I put it all together? The big way is really intelligence. So what we found is we can have a lot of different security tools. Right? We can have firewalls that are doing application visibility and control. We can do intrusion prevention, but they get killed by encrypted traffic. We can do domain name monitoring, IP reputation, or domain name reputation, URL reputation. They get killed by encrypted traffic. So I really have to start looking at all the artifacts that are associated around this behaviors. And that's where good threat intelligence comes in. And there's plenty of folks that do a wide range of threat intelligence. We focus, of course, a lot on the Talos threat intelligence group at Cisco, largely because of the size and sort of breadth of information that they have. But it's been able to be a fantastic resource in doing a lot of the research around what we're trying to accomplish. Right? We actually have the luxury of having the largest threat intelligence or privately held threat intelligence group in the world now. And that gives us the opportunity to see what exploitation looks like on the order of billions of sessions a day. Right? So we're seeing hundreds of millions of threats. Probably every day we're doing a computational analysis on anywhere from 1.5 to 2 million pieces of malware. We're being able to pull in and see intelligence about how domains are being generated and how the internet is actually interacting with itself. We have customers providing telemetry off of malware and file execution behavior inside their own environments, all of which gets sanitized, and we can start to see that behavioral activity. We get the intelligence, frankly, from our own company. The nice thing about having a company of 70,000 people with about 150,000 to 200,000 devices on it is there's a lot of internet intelligence inside of that alone. But on a global scale, when we scale out, we start to be able to see the trends and problems that occur in threat characteristics, each from different tool sets with different sort of perspectives on the visibility. Whether it's being able to look at how emails are being built and generated and types of malicious URLs that are being embedded them and comparing them back against other artifacts, whether it's looking at new IP threat actors and what the IP addresses are, whether it's domains, et cetera. All of that needs to come together into a larger architecture. Right? So the idea is that I start combining the different components from cloud intelligence to what I can see and work with on the network, whether it's NetFlow data, whether it's IP data, whether it's decrypted traffic. The idea now is I get to be smarter. Right? So I think the takeaway, hopefully, is that I try to be mindful, and you can ignore the product names. I try to be mindful of the capabilities I want to deliver for the traffic flow that I'm trying to protect. The way I look at it architecturally is when I'm trying to decide what to do with encrypted traffic, I can't just bring in a sledgehammer and say, decrypt it all. That's not going to happen. and I can't turn off the internet. So I now need to start being mindful of what the capability is that's going to be most appropriate for that session and apply the best type of capability at that layer. Right, so maybe it's doing flow analytics. Maybe it's doing, hey, okay, look at that, the button's working. Maybe it's starting right here at the endpoint, right? Trying to actually be able to look at what type of malware may be landing on it, may be executing, may exist. What are the sort of endpoint behaviors? Then it's going out and doing recursive DNS, trying to identify, are any of these requests known good, known bad, unknown, and make appropriate decisions about how we handle that. It's about having good sort of policy and access controls, where I can start segmenting off segments of my environment based on the degree of assurance. I have an IoT infrastructure that I don't have any good endpoint operational control or visibility into. Am I going to give that access to the regular part of my network? Hopefully not. Could I do behavioral analysis on IoT components with things like NetFlow data? Absolutely, I can. So I want to make sure that that's considered in whatever the flow of data is for that particular device, entity, component, whether it's on-net or off-net. And this is just one example, right? It's a flow of an employee going to the internet. But they're going to have encrypted sessions or some type of threat potentially embedded inside the traffic. Well, certainly I can do my network-based malware, my geofiltering, my IPS, my app control, but ultimately I'm going to have some way to make intelligent, informed decisions. Whether they're land deployed or cloud deployed really doesn't matter. Think about how you're going to get the best scale for making the right decisions on the traffic that you want to be able to control and investigate. Right. End of the day, it's really about building a good architecture. I don't think we're ever going to really solve the encryption problem because we need it, we want it, and we can never turn it off. So hopefully I've woken you up a little bit. Hopefully I haven't bored you or rambled on too much. We're more than happy to talk about what Cisco can do on an architectural basis, and that's actually the role that I provide, is I look at our customer solutions not just to a specific problem or a specific product, but how we can bring capabilities across an organization's environment to ensure more effective threat response. And otherwise, thank you for your time this morning.